Here's my setup. I put the phone on its stand 142 inches away from the subject at a height of 41 inches. I have it in vertical position or portrait position. I use the built-in level to straighten and avoid misleading data, especially regarding symmetry. You're going to want to use a tripod or lean the phone against an object to maintain it still and as straight as possible. You're going to want to centralize the subject. This will help you avoid lens deformation, which is more common at the edges of the frame. When opening the camera, we're going to select SLO-MO and then tap the top right corner. Make sure it's set to 240 frames per second. I'm using the default 1x lens. When recording slow-mo video on an iPhone, you should pay close attention to the slowdown and ramp up of video speed made automatically on the phone. Usually it starts at regular speed, slows down 8 times, and then it comes back up. For our analysis, we need to make sure that the entirety of the video is at the FPS setting we want. To achieve this, you can select the video and enter the editing interface. You can see the timeline at the bottom has dots very close together on the ends and are spread apart in the middle. This represents the speed setting. By dragging the speed selection bar all the way to the end on both sides, we can have it in slow motion for the entirety of the video. Then tapping on Done, the video is saved to your device and can be copied or transferred to your computer. After all my jumps, I made the time edits and trims, then moved the videos to my computer. In my case, since I use a MacBook Pro and an iPhone, I can send them via AirDrop. By default, this saves them to my downloads folder. When I sit down on my computer, I go to Factorial Biomechanics, log in, and choose my file from the downloads folder. I play the video until the subject is in position, then pause. I then open the calibration drawer, enter the real-world measurement. In this case, it's my height, 5.5 feet, or 5 feet and 6 inches. And then I click on Draw Reference, and click the top of my head and the point between my feet. You can see the line that represents the length calibration. When selecting the video speed, I take into account that I recorded at 240 frames per second, which is an 8x slowdown. So I'm selecting 12.5%. And because I want to analyze every frame recorded, I'll select 240 frames per second in the data sampling rate. Then I click on Apply Calibration. As you can see, the graph axes are updated automatically, taking into consideration the inputs I just made in length and time units. I press play and visualize the rest of the movement. I press pause when the second jump is over. I take this opportunity to trim the video with the gray knobs at the ends of the seek bar. You can see the graphs updating as I select the area I want to pay attention to, which is where the jumps happen. Now I'm going to press the lock button to avoid new inferences as I continue to make annotations on my graphs. On the vertical displacement graph, I select the start and end of each jump by looking at when the foot index traces change drastically in slope. I double-click on the trace to create the node. That node, with the coordinates that show up automatically, will help me visualize the data, and my biomechanics assistant will be able to perform additional calculations from that chart information. And click and drag to select the area of the first jump. See how that zooms in automatically? Here I can double-click on the peak of that curve, which represents the highest point the tip of my foot reached. Double-clicking on the white background scales the graph automatically to fit in the available space. Then I make similar comments on other areas of the graph to compare height differences with varied points. I look at the nose key point and make notes on the baseline when I'm standing straight and looking at the camera. The lowest point in my pre-jump squat, the highest point that I reach, the drop when I bounce back, and then finally the return to standing straight. Then I double-click on the center of mass trace to isolate it, and I make similar comments, so I have a couple different perspectives to compare. By looking at the horizontal displacement graph, and even asking the assistant for ideas, I can start to evaluate balance and symmetry. I can select the points that seem out of range, and when I pop out the picture-in-picture, I can see the video time switch and see if there's something interesting happening at that point. With the data graph, I can see where the widest angles are reached when I'm at the top of my jump, and how my knees bend again after reaching the ground. Remember that we track the center of mass position in this chart too, and it can serve as a reference to the rest of the motion recorded.